Yes, the existing ground bar needs to be replaced. According to the National Electrical Code, specifically Section 250.24, A4, grounding bars and straps must be of a material designated for the use and must be of sufficient size to handle the total fault current that can be delivered to the point of grounding. The existing ground bar appears to be inadequate for a few reasons. Firstly, it is undersized for the number of circuits being served. The fact that you have multiple ground wires under a single screw indicates that the existing ground bar does not have enough termination points to accommodate all the required ground conductors individually. Secondly, having multiple ground wires under a single screw is generally a poor practice and can lead to unreliable connections. This is because the pressure applied by the screw may not be evenly distributed across all the conductors, leading to some conductors being loosely connected. This can increase the resistance of the grounding path, which is undesirable. A high-resistance grounding path can impede the flow of fault current back to the source, which is necessary for the overcurrent protective devices, such as circuit breakers, to operate correctly. If the fault current is limited by a high-resistance ground, it may not be sufficient to trip the breaker quickly enough, potentially leading to overheating, arcing, and fire hazards. Thirdly, a proper ground bar provides a dedicated and secure connection point for each grounding conductor. This ensures that each circuit has a reliable low impedance path back to the source. This low impedance path is crucial for clearing ground faults quickly and safely. By replacing the existing ground bar with a larger one that has sufficient termination points, you can eliminate the practice of having multiple ground wires under a single screw. This will improve the reliability and effectiveness of the grounding system. When selecting a replacement ground bar, it's important to ensure that it is properly sized for the number of circuits being served and that it is made of a material suitable for grounding applications, typically copper or aluminum. The ground bar should also be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories UL, to ensure that it meets the applicable safety standards. Installing a new, properly sized ground bar will provide a more robust and reliable grounding system, which will help to protect against electrical shock, fire, and equipment damage. It is a critical step in ensuring the safety of the electrical system and the occupants of the building. Furthermore, the NEC mandates that all equipment grounding conductors be connected to a ground bus that is connected to the neutral or grounded conductor at the service equipment. This ensures that all metal parts of the electrical system are at the same potential, minimizing the risk of electric shock. In a high-rise apartment complex where multiple units are fed from a common service, it is especially important to maintain a robust and reliable grounding system. This is because a fault in one unit could potentially affect the grounding of other units if the grounding system is not properly designed and installed. The fact that the feeders are tapped at each floor unit means that each unit's electrical system is essentially a sub-panel fed from the main service. Therefore, each unit must have its own properly sized ground bar connected to the equipment grounding conductors for all the circuits in that unit. It is also important to ensure that the grounding conductors are properly sized according to the NEC. The size of the grounding conductor depends on the size of the ungrounded conductors that feed the circuit. The NEC provides tables that specify the minimum size of the grounding conductor based on the size of the ungrounded conductors. In addition to replacing the ground bar, it is also important to inspect the condition of the existing grounding conductors. If any of the grounding conductors are damaged or corroded, they should be replaced. It is also important to ensure that all connections are clean and tight. Loose or corroded connections can increase the resistance of the grounding path, which can compromise the effectiveness of the grounding system. When making connections to the ground bar, it is important to use the proper connectors and tools. The connectors should be listed and labeled for grounding applications. It is also important to follow the manufacturer's instructions for installing the connectors. Using the wrong connectors or improper installation techniques can result in unreliable connections. Finally, after the new ground bar has been installed and all the connections have been made, it is important to test the grounding system to ensure that it is working properly. This can be done using a ground impedance tester. A ground impedance tester measures the resistance of the grounding path. The resistance should be as low as possible, typically less than 1 ohm. If the resistance is too high, it indicates a problem with the grounding system that needs to be corrected. In summary, replacing the existing undersized ground bar with a larger one that meets the NEC requirements is a critical step in ensuring the safety and reliability of the electrical system. It will provide a dedicated and secure connection point for each grounding conductor, improve the effectiveness of the grounding system, and help to protect against electrical shock, fire, and equipment damage. Remember to always follow the NEC and local electrical codes when working on electrical systems. If you are not comfortable working on electrical systems, it is best to hire a qualified electrician. They have the knowledge and experience to perform the work safely and correctly. Always energize the circuit before working on it. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Double check all connections to ensure that they are tight. Test the grounding system after the work has been completed to ensure that it is working properly. Furthermore, the inspector's approval to change the guts of the panels rather than ripping out all of the existing panels is an important factor to consider. While this can save time and money, it is crucial to ensure that the new panel components are compatible with the existing enclosure and that the overall installation meets all applicable codes and standards. When replacing the guts of a panel, it is important to consider the following. Firstly, the ampacity of the new main breaker must be compatible with the ampacity of the existing feeder conductors. The main breaker protects the feeder conductors from overload, so it must be sized appropriately. Secondly, the short circuit current rating of the new panel components must be adequate for the available fault current to the service entrance. The short circuit current rating indicates the maximum amount of fault current that the panel components can safely withstand. If the available fault current exceeds the short circuit current rating, the panel components could fail, potentially leading to a dangerous electrical arc. Thirdly, the wiring diagram and labeling of the new panel components must be clear and accurate. This will help to ensure that the panel is properly wired and that it is easy to identify the circuits. Fourthly, the panel must be properly grounded and bonded. Grounding and bonding help to protect against electric shock and fire. Fifthly, the panel must be installed in a location that is accessible and well ventilated. This will allow for easy maintenance and prevent the panel from overheating. Sixthly, consider the age and condition of the existing panel enclosure. If the enclosure is damaged or corroded, it may need to be replaced. Seventhly, the existing panel should be properly labeled to identify the circuits. Eighthly, the panel should be inspected to ensure that it is free from any defects or hazards. When selecting a replacement ground bar, it is important to choose one that is compatible with the existing panel enclosure. The ground bar should be the correct size and shape to fit in the enclosure, and it should be made of a material that is compatible with the other components in the panel. It is also important to ensure that the ground bar is properly insulated to prevent accidental contact with energized parts. The location of the high-rise apartment complex in Indianapolis, Indiana, may also have specific local electrical codes or regulations that must be followed. It is always a good idea to check with the local authorities to ensure that the electrical work is being done in compliance with all applicable codes. It's also important to document all the work that is done, including the replacement of the ground bar. This documentation should include photographs of the existing conditions, the new ground bar, and the completed installation. It should also include a record of the tests that were performed and the results of those tests. This documentation can be helpful in the future if there are any questions or concerns about the electrical work that was done. In addition to the NEC requirements, it is also important to follow any manufacturer's instructions for installing the new ground bar and other panel components. The manufacturer's instructions may provide additional details or recommendations that are not covered in the NEC. Ignoring the manufacturer's instructions could void the warranty or create a safety hazard. Remember to take all necessary safety precautions when working on electrical systems. Always to energize the circuit before working on it. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Double check all connections to ensure that they are tight. Test the grounding system after the work has been completed to ensure that it is working properly. By following these guidelines, you can ensure that the FPE panel upgrade is done safely and correctly, and that the electrical system is properly grounded and protected. This will help to protect the occupants of the building from electrical shock, fire, and equipment damage.